My name is Hadi Farhangi on Basics of Statistics, Correlation. Topics of this video: first, introduction, then correlation, measure of correlation, interpreting correlation, and significance of correlation. Next topic, introduction. Variance is the average of square distances from the mean. Well, sort of. Here's a formula. S square is the summation of square distances from the mean divided by n minus 1 instead of n. That's why it is sort of average of square distances. The standard deviation is the square root of the variance. So S is a square root of S square, which results in a standard deviation. Here's an example. We have 5 observations of variable x. To calculate the variance, we find the deviation from x bar for every value. First value is 90 and x bar is 99. So I subtract 99 from every of those observations. The first is 90 minus 99, which is minus 9. Second, 105 minus 99, which is 6, so on to the end. Then I square these distances. Minus 9 square, 81, and all the way to 1 square is equal to 1. And the variance is the summation of these square distances divided by n minus 1. N is 5 observation. Summation of all those values, 135, divided by n minus 1, which is 4, which is 33.75. So S square is 33.75. Scatter charts draw 2 or more variables against each other, variable versus variable. Every axis displays a separate variable. Every point in the chart corresponds to the values of both variables for a particular observation. A scatter chart is usually used to investigate the relation between pairs of variables. Here are 5 hospitals, number of patients with migraine and injury. Every point observation is every row. One has to find the values of each variable in its corresponding axis. The result will be following a scatter chart. As you can see, there are 5 hospitals. Number of injury for every hospital and number of migraine is recorded and as dots. Next topic, correlation. Correlation shows the possible relation between variables. Data in table shows the price of TV brands and the number of sold units in a retailer. The data has 5 observations and 2 variables, which are price and units sold. The scatter plot looks like this. So for every point, I draw the for every observation, I draw the corresponding point. And as you can see, there is a trend line. The figure shows a decreasing trend. It means by increasing the price, the unit sold decreases. Here are some possible trends. In a trend in a scatter chart, it can be no trend, which is a horizontal line. It can be a negative trend or decreasing trend, or it can be an increasing trend or positive trend. Negative trend, it's a decreasing trend. When one variable increases, the other decreases. Positive trend, it is an increasing trend. When one variable increases, the other increases as well. When there is a trend in a scatter chart, there is a possible correlation between variables. Next topic, measure of correlation. Variance is the average of square distances from the mean somehow. Variance is defined for one variable. Assume there are 2 variables, x and y. We have their variances. Variance of x is shown by subscript x. So S2x or SXX. Variance of y Same way, subscript of y, so S2y or SYY is the variance of y, and the formula one for x, one for y. Covariance is similar to variance but for two variables. So covariance of x and y is SXY, and is somehow sort of average of distances of these two variables being multiplied together from their means. Coefficient of correlation is the normalized covariance. So correlation of x and y is covariance of x and y, SXY, divided by a square root of multiplication of variances, as you can see in the formula here. Calculation of SXY or covariance of x and y is similar to variance where a table is used. Consider the following example. And here's the example. Using the data in the table, calculate the covariance between variables price and units sold and their variances. Then calculate the correlation. Here's the table. We have the different TV brands, their prices and unit they sold. And we are going to use a table similar to variance for that. There are 5 observations in the table, hence n equal to 5. Assume variable price is shown with x and variable units sold is shown with y. Then x bar is 1400 based on table, y bar is 42. And here I create a table. Calculate x minus x bar, 17 minus 1400, 300, y minus y bar, 35 minus 42, which is minus 7. Square the distance of x and x bar, which is 300 a square, 90,000. A square of y minus y bar is minus 7 a square, which is equal to 49. Multiplication of deviation of the distances from x and y for that particular observation, 300 times minus 7 minus 2100. The same way you do all the calculation, and we use the last 3 columns to calculate variances and covariance. SXX is the summation of values in the column x minus x bar squared divided by n minus 1, which is 7500. For SYY, summation of the column y minus y bar squared divided by n minus 1, which is 107.5. For SXY, summation of last columns divided by 5 minus 1, which is minus 226.25. And correlation of coefficient of correlation, or R, is SXY divided by SX, square root of SXX times SYY. SXY is minus 2625 divided by a square root of 70,000 times 107. If you do the calculation, it will be minus 0.92. Next topic, interpreting correlation. The following figure shows how to interpret the value of correlation coefficient. It changes between minus 1 to 1. When it is minus 1 over 1, it is strong. When it is 0, it is weak, or close to 0, it is weak. Here's the example, the case of perfect negative linear relation between variables. When it is minus 1, when it is 0, no relationship. When it is 1, perfect positive linear relationship. R square shows the percent of variance of one variable that is explained by the variance of other variables. So once you have R, you square it, and it shows the percentage of one that is explained by others. And a lot of times softwares return R square. Significance of correlation. One may use hypothesis testing to test where a correlation value is significant. Here are the steps to investigate the significance of correlation. Step 1, setting of hypothesis. So H0 rho equal to 0, HA is not 0, which means it becomes significant. Step 2, calculate critical value. TC is R times n minus 2 the square root of n minus 2 divided by 1 minus r squared. Step 3, calculate p-value. P-value is 2 times probability of t less than equal to that critical value of tc. You calculate the step 2. Step 4, reject h0. There is significant relation if p-value is less than alpha. And you don't need to know how to do this without knowing hypothesis testing. Once you know hypothesis testing, you can come back and use this.